So today we're going to discuss about another new topic about the future vehicles. I think for last more than 10 weeks, we've been discussing various topics in EV, but I'd like to see that how do we think about the EV development in the future? For instance, what will be new component, new operation, and new research area we are looking into. Obviously, we may think about, we do have an autonomous vehicle. Autonomous vehicle must be a future topic. But we know that today we do have many autonomous vehicles. So what further work we can work on for autonomous vehicle? EV component. So besides battery, what other topic we can look into? How do we see the future for electric vehicle? That will be something quite important we can look into. So that's why you can see that my question to you all will be, we know the present state for each vehicle and the design. So how do you see this kind of development, how it carry forward? For instance, in next 5-10 years time, what will be the EV design look like? How do we improve the EV design at the moment? At the moment, just now, we discussed about the hydrogen vehicle, maybe battery vehicle. We can compare them with the price, or the convenience, and also the carbon emission. So in the EV future design, what are the criteria you may think of to govern your future development? So which one do you think is the most important consideration for future EV design? Yes.
I think efficiency and lightweight. Because we don't have to worry about prices so much right now. Because always in the starting of any technology or development, right? The prices are going to be high.
Yeah.
Like even for the lithium batteries, the prices were pretty high in the start, but now they're not so much higher. So the main thing when I think about the future development is the solid state batteries.
Sure. Any new technology, when it needs to go to the market, it's expensive, but it's getting lower and lower. Just like computer. I remember when I was young, I mean, in 1990, when I buy my first computer, it was so expensive. I think several $1,000. But now they several $100. Yeah. So you can see the price quite different. And performance even better, right? So that means when the time go by, then we can see that the cost mass production will be much improved. So that means we are not quite care too much about the cost, but more, I mean, the general public, we do care about the cost. But however, for many users, they also think about other scenarios, maybe convenient, some good looking, or maybe high technology, they may think about this. So that means we're also looking into the future control method for EV. Control method not only about the EV safety, but you're also looking into what other function EV can do. The overall EV system, we have multiple EV, many EV in the city, in the market. How are we going to manipulate them, control them? And more importantly, will be about the energy consumption. Yeah, as we mentioned before, how we're able to make use of the existing electrical power to power all the EV. So we have a shortage of electrical power at the moment if all the vehicles are converted into electric. Today we talk about AI. So that means, will AI become getting more and more important for EV? I think so. AI will be important for everything. AI for everything looked like 50 years ago we first developed the calculator. Then calculator will be something quite straightforward, right? So that means AI will be something integrated with all the components. So that's something we will look into for future EV development, EV design, and EV application. So today we're going to discuss a number of topics, including some major components, advanced EV components, what we're going to look into. What other components can be further improved in the future vehicle? Charging system. Of course, charging is so important. It's the input energy for the EV. So how are you going to look into that? And then for component point of view, the battery. Not only battery nowadays, we also talk about other type of the energy storage, including the supercapacitor or the lithium supercapacitor. maybe other type of energy storage like the flow battery, maybe nuclear shell. So many things can be possible. Number 5 will be autonomous vehicle. Of course, all the vehicles today do have some kind of the autonomy. So how are we going to deal with them? What's the future development on this topic? And then once we got autonomous vehicle, we may think about the connection, how the vehicle can be connected. We call it connected vehicle. So that could be one of the major topics. When all the vehicle has certain computational or AI component, then the connection will be getting more easier and much better. So how we communicate between the EV can make a better advantage. Number 7 will be sustainable. So we are thinking about at the moment, the EV development, many components inside are not really sustainable. For instance, about the battery. Most of battery is only about single lifetime. At the end of the life, we just landfill. So that's not really economic. So that means we need to think about how we're going to make the material used in the EV become more sustainable. So that's an important area. At the moment, you see, most of mass production today, we only think about how we manufacture the item become low cost. We did not think about the recycling. So that means you can see that every day when you go to the transfer center, the dump site, you see a lot of the rubbish, garbage there. They just throw away the old model because they don't care about how to recycle them. I think as the green technology or the environmental pressure, I think we need to look into how to use a more sustainable material. And the next thing will be about the human-machine interface. We are human, we control vehicle, which is a machine. How is the better way to interface them? So you call HMI. We do have so many different types or configuration for HMI. So how are we going to improve that? So how do we control vehicle? At the moment, we're using autonomous vehicle, but in the future, how are we going to connect them? Connect the human to the machine. And also that relate to the user experience, how the user experience can help us to determine what's the best way for HMI. And then we're also looking into centralized, decentralized control in the EV design. There's a lot of the configuration architecture in the EV system. No matter inside the EV or outside the EV, we also have different kind of the configuration. So we're going to look into that. So that's the topic we're going to look into for the future vehicle development. So first of all, let's go to some quick revision. I think we know that a lot of the area in EV, we do this have some significant improvement, including energy storage. We always complain about the battery, right? The battery, including the energy storage, the density, the safety, how to make it low cost, and recycling problem. We always need improvement. So that could be one of the EV research topics we need to look into. And autonomous vehicle. We do all the vehicle like Tesla, then will be a full self-drive capability. Once you pay $100 per month, they are able to provide that to you. But however, there's still a lot of the issue for autonomous vehicle, including we need some training. We did have a lot of data for training. So the vehicle being trained in the US, if you move the vehicle to mainland China, probably may not be working really well because the road conditions are quite different. So we do have a large database for the vehicle to understand the environment, to train them. So because there's a lot of the scenario the vehicle need to learn. So, and also how to program the autonomous vehicle to have different functions, respect to energy saving, operation, convenient, and also many of the nighttime, whatever. There's many things we need to program for different direction, different performance. And also the charging. The key thing for each vehicle about the charging time. At the moment, rapid charging, ultra fast charging, say 30 minutes. So of course, users prefer to have 3 minutes, right? So that means how are we going to do that? We know that we can't have too high speed of charging, mainly because the power source. We don't have sufficient power source. The charger power become 10 times higher. That's impossible for power electronics. The size for the charging network will be too high. So impossible. So we have difficulty how to understand how to proceed with ultra speed charging. And then we're also looking into energy saving, how to overall to improve the energy saving by improving the efficiency for each of the component or operation. So vehicle to everything is something have been talking about for last at least 10 years. So we try to look into vehicle will connect to many other systems, including vehicle to vehicle, vehicle to building, vehicle to customer, vehicle to whatever. So many things we can connect it. So how to explore that, how to best perform that with something we need to look into. And then we're looking into EV component point of view, beside battery, right, charger. We're also looking into many other internal components. Many components in the past are mainly based on mechanical, numeric, or some kind of hydraulic system. But once you have electric, you can convert them into all electric components like the suspension system, braking system, steering system. You can all convert into electric. So that means how we develop this component. We do have many of similar components in the EV, but we like to see 100% electric. Would that be possible? Which component we can do further to become more electric? So that's the thing we need to look into. What else can you think of besides this field? Can you think of any other EV improvement you like to pursue? Any comment for this page? You've been working this for nearly 1 semester, right? What other improvement you like to have? Next research area you like to have? I try to get more idea from you so to write my proposal, right? You see, this is a major area we are now having for EV, but I may overlook something. I need your support. What do you think? What next? Think about that. I will have one question in the final exam. One question will be, what do you think of besides this? What other area you may think of for EV future development? Okay. Anyway, let's look at different parts first. You see, for advanced EV parts and component, you have many development on motor. We like to develop some new motor, intelligent motor, high performance motor. Even the inverter to drive the motor, we want to find about different kind of motor to do that. That including how we integrate the motor together with the inverter. We're also looking into many power converter. In the EV, we have to manipulate with different voltage. So we do need to have higher efficiency, high power density for the converter. Like the charger, we think about in the next few more years, the charger power level needs to be go up. So instead of 30 minutes, say 3 minutes, may not be 3 minutes, 10 minutes, then we do anyway increase the power to a few times higher. Such a high power, how are we going to do that? How to increase the power electronic to do the job? Motor. We tend to integrate the motor and the wheel together. So we so-called the technology called direct drive. Direct drive is some technology we like to see to do with the connection between the motor and the wheel. So we call direct drive try to minimize the physical connection between the motor and the wheel. So in this case, we can reduce all the mechanical connection. So that means even motor is working on this. But how we combine them together? So in this case, we can reduce sharp gearbox, clutch, transmission, many things we can reduce that. So that's the thing we need to look into. So, and then once we do EV motor, I think I also mentioned to you the other day, once we do that, then we can save a lot of the space and design in the vehicle. And next component is the suspension system. At the moment, most suspension system, we are using hydraulic suspension because the vehicle is so heavy. Just like you can see that the Tesla vehicle, many EV are, say, 4 tons. So heavy, we do need to look into how to develop the suspension system. You can see that in many vehicles, if you try to sit on a Tesla vehicle compared to a gasoline vehicle, the major difference will be the suspension. If you see that the suspension for EV not very good. The key thing is, of course, the EV company usually they are not orientated in the mechanical design, they're more in the motor battery design like Tesla. So that's why the technology for suspension is not that good. Next thing will be the vehicle's quite heavy. You see the battery, the whole vehicle body are suspended by the suspension. So that means you see 4 tons of vehicle, you need to add suspension to suspend the vehicle is not an easy job. If the vehicle is 4 tons, each of the suspension need to control 1 ton of the force. And then that little cylinder for the suspension need to control 1 ton. It's not an easy job. For normal gasoline vehicle, similar car probably only about 1.5 ton or maybe 2 ton. So the demand for suspension much easier. So that's why the only thing you complain when you sit on Tesla will be the suspension. Whenever the vehicle go through the ramp and even surface, you find it too bumpy, a lot of vibration, which we don't quite like. But if you try with other conventional vehicle, you find it quite okay because the suspension has been there for many years. But having said that, the suspension technology still need to be further improved. The conventional suspension, we use hydraulic system. Hydraulic system, that means able to provide high force. But hydraulic system will be not adaptive. Not adaptive, that means if your vehicle pass through a lot of the hump or uneven surface, you can still see the vibration because all the road area are all different. You can't have single suspension to able to adapt for all the different road surface. So that's why conventionally this suspension called passive suspension or passive suspension. They use some electronic to control them, make it better to use electronic pump to control hydraulic liquid. But that is still more passive-like. So the better way to do with active suspension, you use linear motor or some electronic actuation system to replace the suspension. That's the future work we need to do. Next thing will be the sensors. Our vehicle today, we're getting more and more sensor nowadays. Conventional vehicle, we don't have that many sensor. We may have something called the tail sensor to detect when you do the reverse, maybe other sensor, but not. But today, electric vehicle have many sensor. Like a Tesla vehicle, 8 camera to view all the angle. And then you also have GPS and also a lot of the speed sensor, many things. So in the future, we need to think about how to integrate all the sensors together, called the sensor fusion. How to fuse them together and then to see which sensor would be more important for the driving condition, for present road condition. So that's important. Another area will be battery management system, BMS. The battery getting more complicated. So today we not only talk about the battery could be something else, can be supercapacitor, can be integration between battery and supercapacitor, can be fuel cell. So all this energy management system, not only battery, but energy management system, will also need further work. So how to ensure that each of the battery cell inside the battery system are in good condition, healthy, and safe, can share the voltage and current properly. Because a vehicle have 100 of the cell. How to make 100 of them? You can't put on 100 of sensor, too expensive or too costly. You don't know which one is which, right? So that's also a lot of management thinking. Next topic will be wireless power charging. So wireless power is something getting important. So just like when we charge the phone, we have a wireless power transfer. Then vehicle as well, we also look into the wireless charging. So just now we mentioned about when we talk about V2G, we like to have wireless power charging. So that must be further developed. So however, at the moment, really few vehicle, especially commercial vehicle, have wireless power charging yet because the atmosphere, the facility not here yet. But that will be really important area of development. Just like, as I mentioned before, phone charging 20 years ago, we don't think about wireless power charging. But today, most of phone able to have wireless power charging. So it takes time. So these are some area we may think of for vehicle point of view. What are we looking into for future advancement? So for instance, e-wheel motor, like this vehicle I developed some time ago. So the motor here, the wheels here, this wheel are integrated together in a single component. The major advantage, of course, we know that we can reduce a lot of this interior design. Interior, we don't need anything. We have no shaft, no gearbox, no clutch, no transmission. We've got more space in the middle to do whatever we like. So that's why the design vehicle much easier. So that's why you can see that today electric vehicle, we don't need to have a rear seat, particularly on the rear axle, before we usually have that. And the central part, in the central console, we don't have any transmission there. So in this case, the central part, we don't have this kind of the pump there. So we can have a fast service on the EV nowadays. So the design, because of using the e-wheel motor, we're able to improve the interior design much better than in the past. And also, of course, we're looking into the weight. The weight will be much lighter. And also efficiency could be higher. Why is that? Because we eliminate all the mechanical connection. Just like we mentioned about gearbox, clutch, transmission, shaft, they all eliminate. If each component 90% efficiency, we eliminate 4 of them, we have improvement for 40% efficiency. That's nice to have. And also, but the problem, the design will be top. Because most of the motor development will be usually a few thousand RPM. But do you know what is the RPM for the wheel? What's the RPM for the wheel? Xiaodong?
Too much about.
Yeah, you are driving vehicle, you have a license?
Yeah.
Yeah, what is the RPM for the actual wheel we are using? The range. How about what the normal RPM for the wheel?
For a wheel?
Not for the engine, for the wheel.
Oh, no.
Much lower than the engine, obviously.
Which is
Way. And high speed, I think, I'm not sure, it's just a vague guess. It should be around 200 or something.
Oh, yeah. The range usually about a few hundred, 500 to get long. Really rare to go up to 1,000. So usually about 200, 300, 400, 500 as a maximum. But the motor usually will be 3,000 RPM, maybe 5,000 RPM. So they are not compatible. So usually for most of EV, they do have a gearbox, roughly 1 to 7, to reduce the speed to servo. Even the gearbox fixed gear ratio, but we still need a gearbox anyway. You see a motor inside the wheel is so tight, no space here. Then you also need to put a gearbox and motor winding, electrical connection. It's quite difficult design anyway. So that means this is still have a lot of challenge for the future EV development. How to make it high torque. For high torque, you need to low speed. Lower speed, then you impossible. As I mentioned before, the power equal to E and F equal to say half Li squared F, right? So if you can only increase the power by increasing current or increasing the frequency. But in this case, if you want to reduce inductor means the winding inside, right? So the only thing you can have to reduce this one to increase the frequency. So for motor point of view, if you want to have a smaller size of motor, higher power than the motor, you need to increase the rotational speed for the motor. That's the physics. You can't do anything else than that. But as I say, the e-wheel motor will only about maximum 500 RPM. So that means so you need to design motor at lower speed. The motor size becomes bigger. Then in this case, you can't fit inside the wheel. So that's the physics. So that's the design difficulty for e-wheel motor. You need to put some gearbox. So maybe we already think have a lot of development, like magnetic gearbox, star gear, that's something we have been looking into. So that's a really important area for development for better in-wheel motor design and also cooling. At the moment, the Tesla vehicle or other EV vehicle, the motor is quite small, this kind of size, for 100 kilowatt, 200 kilowatt. That's impossible. Look at 40 years ago, 200 kilowatt motor will be that size, but now become that small size. Why they can do that? The magnetic is not changed that much. The magnetic design cannot change from that size into that size within 50 years. The Maxwell equation is still the same, but what they have done,
Frequency, increasing, that's
frequency, yeah, partly frequency, high frequency, but frequency is not the case. Rotation speed is determine the size of the motor. We still prefer to use 3,000 RPM, 5,000 RPM. If we due to rotation speed for the wheel, 500 RPM still a disaster. But what they have done will be force cooling. Why their vehicle become motor been so small? They use smaller copper, smaller iron, less iron, but force cooling, liquid cooling. In this case, they can remove the heat instantly. They always keep the temperature for the winding and wheel to the low, so they don't produce any more heat. They're just using a pump to pump the liquid to cool. That's the way to improve the power. So that's why, but for in-wheel motor, can we do that? Can we have force cooling? More complicated, because the wheel is rotating. How you can deliver the liquid to the motor? Most of the in-wheel motor are using air-cooled. So then air-cooled, liquid-cooled are different by so many thousand times. I mean, so that's why we have a lot of difficulty for in-wheel motor design. So that's all the research area we look into. And there are also the fault tolerance, because anything exposed to the atmosphere, the fault condition need to be reconsidered. We have less protection, right? People will think, oh, exposed outside, there can be damage, there can be a dust, water, shielding, everything need to be reconsidered. So that is the thing we look into all the research area for the in-wheel motor. So that means the further development, including efficiency, performance, overall design, how to reduce the losses, space optimization. You need to integrate the motor design, magnetic design, and also gear design there, how to optimize them. Which one will go first? How much portion put on the gear, how much portion put on the winding? How to fit the whole thing with the vehicle. So that's something we need to look into. And also enhance the performance, the motor drive. So usually, nowadays, we tend to put the motor driver, like the inverter together, the motor, integrate them in a single component. So inverter integrated in the in-wheel motor as well. We try to integrate them. So sometimes you think about, can we also put the power electronic inside the motor? Especially also for the in-wheel motor. This is another topic we need to look into. So in this case, we can able to just put DC wire to the in-wheel motor that will simplify everything. So that's another interesting topic we need to look into, also major topic. And modular design, how to make the motor become modular. So in this case, we can just, if you want to change the motor, quite straightforward, you can just use a modular method to change them. And also how to control that. And not the control method to do that, the control including the safety, the steering, the power conversion, and also a lot of optimization we need to look into. And then we're also looking into material development. What kind of material we can use? That material should be able to expose to wide temperature environment. You see, when a motor inside the vehicle chassis, then temperature are more controllable. But when the motor is outside the car body, the temperature variation can be much larger. And you can see that, for instance, you can some material, magnetic material inside, you expose to the external part, then during the day, temperature can be really, really high. At night, the temperature can be really low. the magnetic material could be a problem. If you use a PM, permanent magnet, for the motor, then probably can have smaller size of motor. But permanent magnet is not really happy about wide temperature range. Especially at high temperature, you lose magnetization. So that's the issue. What would there be any innovation for material to do? And how to reduce the rate, improve the efficiency? That's also something we need to look into. And also sustainable, how to make the all material manufacturing capability become always sustainable. Material can be recycled. Yeah, because you see, a motor, when you expose the atmosphere, probably the lifetime may be reduced. Then we may need to replace the motor maybe more often than before. So then in this case, we may need to think about, can the motor become sustainable, recyclable? Another issue about the braking. Motor, of course, itself can provide its electronic braking. But usually for all the EV motor, by law, we also need to implement with the mechanical braking for the safety. Yeah, one will be for electronic braking using the power regeneration, plus mechanical braking for safety, for last moment braking. So that means when you put them together, we got two braking systems inside the vehicle. Plus, you're also looking into anti-lock braking system. Lock means usually the brake pad or the shoes pad to brake. You're also looking into implement ABS, anti-lock braking. So there's a free braking technology you all need to put into the EV motor. So how to manage them properly is something we need to look into. So another area, important area, is called the active suspension. Suspension are now is not a so critical component. Without suspension, the vehicle can still move, but it just feels too bumpy. You're not comfortable. And a nice suspension, when you sit on the vehicle, you won't feel anything when the vehicle traveling on road, on any road surface. So suspension mainly is to cancel out the vertical acceleration. When you eliminate the vertical acceleration due to gravity, due to bumpy surface, then that is the function for the suspension. Conventionally, all the suspension are using hydraulic system, maybe electro-hydraulic. But however, the speed is not good enough, not have high dynamic response. But today, when we're looking into this research area of future development, we want to use motor, 100% motor, to replace the hydraulic, because linear motor, can able to 800 times faster than hydraulic system. So that means in the vehicle, when you transfer any pump surface or uneven surface, all this vertical vibration can be canceled out. So that means suspension mainly is adapted to the vertical unwanted acceleration due to gravity, due to the road surface. So in this case, this diagram is show you, this one of my development. We use 4 linear motor to control the 4 corners of movement. Whenever you detect any ramp, any pump, uneven surface, you adjust the vertical positioning so that you can able to eliminate any vertical vibration. So that's function of this. So that means we are able to use more active method electromagnetic actuator to replace the shock. So the good thing for active suspension area will be you can able to eliminate hydraulic system, because whenever we use hydraulic system, we know that we need maintenance. Hydraulic system, you need to maintain the liquid there, you have to pump, you need to maintain all the liquid connection. If there's a leakage, liquid meant to have some leakage, that will be end up with other problem. Reliability, once you have liquid flow in your vehicle, then you do have reliability problem. Right? Even though today many of the electric vehicle, they are not using electric suspension, they use electro-hydraulic, even though Tesla, because they don't have that technology yet. So that's why we need, so that is some topic we need to go into. And also you can see that when once we have this kind of the active suspension, any vertical movement, we can convert this energy, vibration energy, to go back to the battery. So in a way, we can have a further energy saving. And also, it's also gimmicky. The thing is, once we do that, then we can able to adjust the vehicle sprung mass. You know what's meaning for sprung mass? So it's a vehicle technology that means there's all suspension here. The suspension will attach the wheel, but all four suspension will try to attach to the vehicle body chassis. All these things are controlled by the suspension. We call it sprung mass. That will look like more sprung. So that is to say, the whole vehicle body, when you sit on the vehicle, the vertical position for the sprung mass can be adjustable by the suspension. You can see that some high performance vehicle, because for some young lady, when they want to sit the vehicle, they lower the vehicle body to let you to sit easier. Once you sit inside the vehicle, they will raise up the vehicle body because they use active suspension to control the vertical positioning. Also, you can see that for city driving, we tend to raise the vehicle body high up because the road surface may not be too even. There are a lot of road surface or a lot of road work there. But in highway, the road surface usually will be more flat. They will lower the vehicle body so that you can reduce the air resistance. So that means the active suspension able to support us for different performance, different kind of road surface. So low speed, high speed, different drive experience can also controllable by active suspension. But if you use hydraulic suspension, you don't have that capability. So that means for future vehicle, we do need to integrate this kind of feature for active suspension to improve that. So the difficulty to design will be how to maintain high force in the vertical suspension. You can see that for electric vehicle, say 4 tons, each of the suspension need to control 1 ton of power, 1,000 kilogram force. That's not a simple job. And also you need to maintain high speed. You see when a vehicle passes through a pump, then you can, that kind of the pump that will be usually about 10 milliseconds, you need to finish all the response. So 10 milliseconds plus 1 ton, 1,000 kilogram force is not an easy job. The power level for the suspension is quite high, but you need to control them with a small column. So that's magnetic design quite difficult. So that's also another area we're not quite sure how to do it properly. We have that demand. For electric vehicle, is low point we have to integrate with hydraulic system. You see the whole vehicle are all battery and motor for everything. But the thing left behind is the suspension. Suspension is still hydraulic. So that's a long things. But we still don't have a good solution how to eliminate the suspension to become all electric. You see, if heavy now and then, when you go to electric vehicle maintenance, you need to check the suspension liquid, suspension performance. You need to, in theory, you don't need to worry too much about maintenance for EV, but not all the components. Suspension is something we need to look into. And also, but another thing will be once you use the linear motor, you need to adjust the vertical position. So that is to say, you may already to produce the power to control vertical position for the sprung mass. Then EV, you want to save energy. You can't always inject energy to the vertical suspension. Usually for conventional vehicle, you don't need to inject any power to the suspension. You're just using hydraulic system, you don't need that. But for electric, you need to always maintain certain energy level. So that's something we're not quite sure. We need to save energy, we want to be more smart, but we don't want to spend energy into suspension. So that's the design, we're not quite sure how to do that. So now they understand the architecture problem, how to design the suspension properly. So EV is not only the battery problem, not only the charging problem.
There are some cars which can adjust their height, right?
Yeah.
You go down.
Yeah.
like, while standing. So that's also the normal hydraulic suspension.
Hydraulic system can adjust the vertical position. Just like when you go for some nice vehicle, they can adjust the vertical positioning. In highway, city driving, when you park, when you get our vehicle, they can adjust it. But they are using hydraulic. Hydraulic can do the job without any problem. But however, the response time for hydraulic is too slow. When you go through a ramp, it's not respond really well. So for different kind of the RAM pump surface, you do feel some kind of the vibration, which you don't quite like. But that's why we go for the active suspension, but still active suspension still have a lot of the issue we need to research. It's not sufficiently to overcome everything, but we like to have an active suspension to eliminate the hydraulic system or the mechanical system. So that's one of the development we like to see in the near future for EV. Another area will be wireless power transfer for the charging. Then, of course, we know that wireless power transfer is actually a major topic in electric vehicle or in power electronics. I think if you look into all the research publication, roughly about 25% of all the paper are in this area. So it must be a big research topic. So many researchers are looking into here, although it's still not yet in the real application, but so many research going on. So that means many researchers, many professors may think that's a really important area. So key thing, you can see that wireless power transfer, mainly for stationary power transfer or for dynamic power transfer. So you can see in this picture, if we want to use dynamic power transfer, we need to put many of the transmitter coil on the road. So that will cost a lot of the investment and also a lot of the implementation. And so that's why I can see that dynamic wireless power transfer getting difficult. Just like many years ago when we firstly developed the lever train. Lever train is quite nice to have, but it's really expensive. So that's why for the whole global development, you don't have that many lever train. We have train. You have electric train, but we don't have lever train that usually only for short distance, a few kilometers for demonstration. We can't have a whole level of 1,000 kilometers with lever train because that's too expensive. I think similar for dynamic power transfer. If we like to have a dynamic power transfer for EV, the technology should be here now. We are able to do that, but the investment is still unsure. So that means the further development will be how to further improve the efficiency, how to make it viable, improve the saturation. Can we make it wider? I think for SUV will be quite okay, but major problem for wireless power transfer, we need to apply them for commercial vehicle. The commercial vehicle are most problematic for the charging. But if commercial vehicle, we are able to apply the wireless power transfer, like dynamic one, that will much easier. But commercial vehicle usually have a larger separation from the car body to the road surface, like the lorry. So that's why how to improve the saturation is something we need to look into. And also, there's a lot of EMI in the magnetic field. How can we reduce the magnetic field? Especially for our object, like human, animal, that's something we're not quite sure. Once we want to increase the power level, in this case, we do a problem for leakage field, a lot of emission. We're not quite sure about how the emission will affect us. Even though for phone, we are thinking about that will cause us a brain cancer, right? But how about for wireless power transfer? Would that be a similar problem? Because the magnetic field will be even higher, much 1,000, 10,000 times higher. Then would that be affecting the user? Especially when you stationary charging, you may not inside the vehicle. But however, for dynamic charging, the driver and passenger are inside the vehicle and also nearby pedestrian. So that's something we're not quite sure about how to examine that. That's not only electrical engineering problem, but more also in the medical research. The investment must be quite high here. You can see the many coil. We need coil, so we need power supply, we need inverter. And then the cost, and it's not quite sure. Certainly will be expensive, but how we're going to reduce the cost, how we simplify the technology, simplify the topology to do that. So that's the thing we need to look into. Next thing is the charging system. So the charging system always become important for EV, right? Just now charging system, we do have prefer to really high power of charging system. So like within a few minutes will be something we like to have. So with high power charging, we need to look into the cooling, thermal management, efficiency, power density, all these things will be a good research topic. Of course, nowadays we tend to use wide bandgap power devices to reduce a portion of the problem, but still the problem is still there. But high power charging is one of the important development anyway. All the research paper, all the major announcements, they all talk about their battery or EV can able to do the charging within short period of time. So that's usually an announcement from EV company or battery company. They try to say their battery or the EV can finish charging in a few minutes. So that's a interesting point, but the technology is still not there yet. Wireless power transfer still need further development, how to implement properly in the vehicle. So there's something we need to look into. And the charging system, also including the research of V2G, vehicle to grid. I think vehicle to grid mainly is to bidirectional charging for the vehicle. Today, all the vehicle, 99.9% of vehicle are not developed for V2G. They only have unidirectional, not bidirectional. Then how to do that? We need a cooperation, maybe international guideline or legislation to do that. The thing is, all the EV companies are separate or are located in different countries, different systems. How can they unify into single system for grid is uncertain. Even though the power grid are all different from different countries. So that's why V2G are really a big problem. It's different from phone. Phone, nowadays we got the USB or USB-C system that much easier to unify the charging. But for vehicle, different vehicle, different voltage. Different country have 108 volt, 120 volt, 110 volt, 220 to 380. They all have different voltage, different frequency, different kind of system. So that means V2G is still a major issue. Smart charging. So how to make sure that charging station can communicate with other charging system. So when we have limited amount of charger, but you got uncertainty number of the vehicle, how to mesh them together. You need to have really good scheduling, very good timetabling, really good power connection. So that's all this thing will be another issue. And also for the safety. Today, we do have another new requirement for the charging station, have the safety implementation, including how, in case one vehicle on fire during the charging, how you're going to accommodate that. As we mentioned last week, during the charging, fire disaster will be much more often than a vehicle in motoring. So that means charging need to look into about the safety as well. Then because of green technology, then we also think about charging should be related to renewable energy. How we implement the solar power, wind power, hydropower, or maybe a solar vehicle together. So that's something we also like to see in the future charging system, how to put them together. So today we are working on a project trying to convert the whole UC vehicle, the golf car, into solar power. So that's something we like to see in the near future, to use solar power to power up the vehicle. That will be quite feasible because for many vehicles, we are using really light load, say golf car, the power level, only a few hundred volts, then we are able to use solar power to produce the energy without using charging. We're also looking into the battery swapping, right? We have been discussing battery swapping for quite some time. We know that will be something happening, but which one will be winner, we're not quite sure. The thing is battery swapping or direct charging is two kind of the separate, completely concept. So, but battery swapping has been quite successful in a few locations and also in scooter, but not quite sure in large vehicle, would that be possible? Whenever talking about large vehicle, we do need to have robot and machine to do the swapping. So in this case, we do need to have a lot of support from the government to do that. So dynamic charging, or so-called the move and charge, is another technology. It's a major discussion in all the charging system. But beside these two, we're also looking into the charging not only by electrical means, but also by other means. So like for flow battery, I discussed with you, we are using liquid form of the charging by charging the vehicle using electrolyte. So that will be much similar to gasoline charging. Of course, battery swapping is another two-way. We don't need to use electrical means to do that. Then another technology, when we talking about the V2G vehicle grid, then we know that the charger must be bidirectional. So you can see that usually when we have AC from the power grid here, then we using this diode to rectify become DC to charge the battery. But because of V2G, we are not using diode only, but we're using transistor. So the DC in here will pass through the 6 transistor become inverter to convert the DC into the AC. So that means for the future bidirectional charger, the inverter or the rectifier must be bidirectional. So that means we need to further control or further work in this bidirectional charging. At the moment, we don't have that because for high-speed charging, we use DC charging. They all are unidirectional. We don't allow the power from the battery back in the power grid. So we don't have that facility. I think in the next 5 years, I don't see that because nobody will sacrifice their battery to the power storage for the PG&E. So we still don't have that kind of the development. So we wait and see for a few more years to see any further work. But we know that this kind of the charging will be getting more interesting. Many research areas are looking into. But for tactics, then we are not quite sure how that can be done. So that's the thing we need to look into. The number 4 about the battery. The future development for battery is something quite strange. Besides the normal battery, we've been talking about like the lithium-ion battery, NMC battery, or the lithium-ion phosphate battery. There's a number of other batteries are being rapidly developed, like solid-state battery. I think we also do some study on solid-state battery. Like I have asked you to check with some YouTube about solid-state battery, right? So the major development for solid-state battery will be the electrolyte will be solid-state. So that will make the safety much easier to be controllable. And it seems that the density, the charging speed, everything can be improved. But at the moment, still very expensive. Still not yet mature yet. So no EV user like to use solid-state battery yet because too expensive. EV already expensive. If they use solid-state battery, that will be even more expensive. So that means we need to wait for 3 more years. Another similar lithium-ion battery called the lithium sulfur. I think from the publication, we see that this also have high potential. They also have quite a few times energy density as compared to the lithium-ion phosphate or NMC battery. So we wait and see for this lithium sulfur to see if they can have further development. Then other battery like the lithium air battery, lithium oxygen. We also have flow battery, and they are all possible. Another thing about the fuel cell, at the moment, hydrogen fuel cell have been developed quite well. But now then we're looking at another development called solid-state hydrogen fuel cell. So in this case, they are using so-called solid-state to do that. So that's another newer technology we're looking into fuel cell. At the moment, the PEM membrane fuel cell are getting some kind of limitation because of the cost and also PEM membrane lifetime and also the efficiency. So we're looking into another new design in hydrogen fuel cell to further improve that. So that will another technology we're looking into. But I think that will take a few more years. So of course, I think in the near future, a vehicle could be a combination of many battery systems, including capacitor, full battery, maybe solid state, maybe fuel cell. They are all mixed together. A vehicle could be more than one energy storage. So that means we need to have a really good battery management system so that we can combine, coordinate all the batteries together. So the material is something also looking into for battery or maybe for many other energy storage devices. We're looking into better material. The better material including the electrolyte, the electrode, and the separator all will need a better material. So for the nano technology, we have been talking about for the electrode material. So today, the electrode are just using solid material, but nowadays we talk about nano material. Nano material in the electrode, we are able to improve the current density. So that means they can handle high current. In a way, we can also improve the overall energy storage density, specific energy. Then this material will also hoping the battery can be recyclable. Today, the battery is not recyclable. So tomorrow we're thinking about if you improve the material, we try to use something recyclable battery material so that in the day of the manufacturing, the battery are recyclable. Rather than today, after we develop battery, we're still looking into another way to recycle them. That will be much more problematic. For electrode, then we are looking into many new materials like the silicon electrode has been working nowadays to improve the electrode capability. And also because some conductive polymer also try to improve the conductivity. So you can see that there's a lot of the new material have been going on for battery development. Of course, 3D printing. We tend to use the 3D printing to develop some more complex battery architecture rather than simply electrode plus a separator. So that's another way we can look into the research area. So other area like the supercapacitor, I mentioned quite a few times, which is quite a nice thing to have. The reason we're looking at the supercapacitor because the technology is here now. We can see higher improvement in supercapacitor every day. The cost getting lower, and most of the safety of supercapacitor much better because we only store the energy in terms of the electrostatic rather than chemical energy. So that means chemical energy usually impose a lot of the safety concern, chemical exposure, but for electrostatic energy storage, usually it will be safer, much easier to manage and add the protection. So lithium supercapacitor is another new trend. We try to integrate the supercapacitor and also lithium battery internally, not externally. Then in this case, the battery, when we manufacture them, we already put in the lithium and supercapacitor capability together. Today, we can tailor make them. We can custom them to be any range from supercapacitor, which is 5 watts per kilogram, to the lithium, usually will be 140 Wh per kilogram. We can do any range. But the one in the market, we can usually see about 30 to 80 Wh per kilogram. So that's to say we can able to use lithium supercapacitor, which have a similar energy storage as a lead-acid battery. But the life cycle will be really good. The life cycle lifespan of lithium supercapacitor usually will be something look like 10,000 cycles, maybe more than that. So that means you are now using something look like lead-acid battery, but have long lifetime and do not have any short circuit problem. Supercapacitor, something like the short circuit can be basically reduced the risk. You can still have short circuit high current, but the capacitor will not get exposure. Chemical battery have exposure because chemical reaction. too high pressure. But for supercapacitor, usually in electrostatic, the risk for explosion will be less anyway. So hydrogen fuel cell is another energy storage you can look into. We tend to use hydrogen fuel cell to replace battery or repair a portion. But we see that the development for hydrogen is still quite slow. Just now we can see the presentation. The hydrogen fuel cell is still expensive, still have a lot of carbon emission. The hydrogen source is still a problem. So we do need to improve that. So you can see that the slow development for hydrogen system is mainly about the infrastructure. We don't have sufficient hydrogen station yet. In many usually stations are inside a city or probably outskirts of a city. If anything, for instance, between San Francisco and also Los Angeles, we don't have that. We only have one fuel cell station. So that's not good enough for intercity traveling. You see hydrogen fuel cell vehicle, we mainly try to use them for intercity traveling, but we don't have that many intercity fuel stations. So that is an issue. We like it to happen, but we don't support it. So that's why we have a big problem for hydrogen vehicle. Also the cost. Cost for hydrogen is still really expensive. There's a low natural resource for hydrogen. In the atmosphere, you don't have any hydrogen. They all become compound, hydrogen compound like water or hydrocarbon. Ammonia, you do have a natural resources for ammonia. So that makes the development quite different. So the slow development for hydrogen fuel cell due to production cost, transportation problem, with storage problem, leakage problem, safety problem, efficiency problem, they all become a major issue for the slow development for hydrogen vehicle. And also other human factors, like including the public awareness and public acceptance, they still scare about the hydrogen. Many people, when they hear the word hydrogen, they may think of explosion. So that's why they don't quite like to use them for EV. And technology, you see for the last 5-10 years, the battery technology has been booming so much. I think 20 years ago, when we started to seriously consider hydrogen vehicle, during that time, battery is still not good enough. During that time, hydrogen vehicle try to compete with the lead-acid battery. Maybe the other low performance nickel kind of battery. Then of course, hydrogen will be much better. But nowadays, today, you can see that the battery performance is so good. We can able to have a low-cost lithium battery for 200 Wh per kilogram. So that means the gap between the advantage for hydrogen vehicle compared to battery getting less and less. And having said that, hydrogen is still quite really expensive in terms of the resources. But battery vehicle, we're able to make use of renewable energy. So that means the technology gap are not that good as compared to before. And also the regulation, the safety thing, storage, everything may not give any advantage to hydrogen vehicle. So probably after 10 years, you may tell me again, what happened to the hydrogen vehicle? What do you think? Do you think hydrogen vehicle after 10 years from now, what do you think hydrogen vehicle compared to battery vehicle?
Still will be difficult to adopt.
Yeah, still difficult. You see, infrastructure for hydrogen is so much hassle. So I don't think 10 years is good enough for hydrogen unless there is some major change in the planet Earth. Otherwise, I don't think there's anything happen. You see, 10 years ago, I heard about lithium battery. The problem because lithium only produced by a few countries in Africa. But now, for the last 10 years, lithium mine has been everywhere. They have new locations for lithium, cobalt. May not be a problem. Although lithium, from my lecture looks, the ranking about number 23, right, for the world production. But we still have a lot of the lithium mine. So we don't have that major problem yet. So the getting low cost, cheaper and cheaper every day. So that's why battery vehicle will be still going on because battery, the response time for battery is good, the efficiency for battery is good, and then we can also use renewable energy to power the battery. But hydrogen, we don't have that many choices. The only thing we have green hydrogen is using solar power. They're really expensive. So that means I don't see a good future. So Japanese people, 20 years ago, they focused on hydrogen vehicle. After 20 years, still didn't see any success. Hydrogen fuel cell has been in the innovation map for 200 years. You can see my lecture notes. 200 years ago, we already developed the hydrogen fuel cell. But after 200 years, nowhere. So that's why in 10 years' time, we are predicting, I don't see any future yet for hydrogen vehicle. But anyway, but for hydrogen vehicle, ground vehicle may not be really successful. But however, we do see some benefit for other vehicle. Because for other vehicle, for transportation, like aircraft, that will be another story. In aircraft, usually the cost is not that significant. For road vehicle, we talk about the cost is a major issue. But for aircraft, we think about the profit margin for aircraft will be much, much higher. We allow more new technology in there. So first of all, for all the transportation, vessel, aircraft, and ground vehicle, each account for 1/3 of the emission. Aircraft have been using oil. So we do have a high emission due to aircraft. So we do need to eliminate that. But we cannot use battery aircraft, impossible, too heavy. So that means the only thing we can do is to use chemical fuel. So, but there's only 2 chemical fuel in the market is zero emission, hydrogen and ammonia. So the only possible way we can power our aircraft for zero emission will be using hydrogen or ammonia. But ammonia developed so slow because only me to develop ammonia vehicle, so we cannot catch up the timetable. But hydrogen has been there. So that means hydrogen aircraft could be one of the major development for aircraft, for aviation. Firstly, because of zero emission, in the airport, in the air, we like to see that battery energy impossible to become electric aircraft energy source because too heavy, impossible. A battery aircraft can only last for 30 minutes at most. So that means definitely impossible. Aircraft usually to travel for 10 hours, maybe more than that. So, but hydrogen will be possible. Even though the cost for hydrogen is high, but because of the carbon emission, carbon footprint, carbon tax, and safety, then we do have an advantage to use hydrogen anyway. The major thing with hydrogen would be a cooling medium for aviation system. Our aircraft, you can see that for cooling, always become a problem because the air density up in the sky will be really low, much lower than on the ground. So if we use forced cooling to cool the equipment, then we end up to be quite a problem because we don't have sufficient cooling capability for thin air up in the sky. But when we have hydrogen, we use pressure hydrogen or liquid hydrogen, then we want to release the hydrogen, we automatically can generate cooling for the aircraft. So that will be really good combination to use hydrogen fuel for aircraft. So that's why we're able to produce better energy transfer. We can use the phase change in the cooling system to support a lot of cooling. And also hydrogen is lightweight, high density. The specific energy is better than ammonia anyway. Because H2 compared to NH3 has a much better in the weight density. Then this pressurized hydrogen can able to support any cooling issue in aircraft. So we can able to use electric propulsion system together with hydrogen to do the job. So that's why we do see a future for hydrogen aircraft, but I do not see any future in hydrogen vehicle yet. Of course, for this kind of hydrogen aircraft, we tend to use hydrogen fuel cell. So that means hydrogen fuel cell together with the cooling performance able to make the aircraft become really, really possible. And also, a lot of the airports have been implementing zero emission criteria. The key reason is all the green association. They do require 100% emission. But the aircraft system is difficult at the moment. They only try to change all the vehicle, the ground vehicle on the airport become zero emission. Today, you can see that many international airports, any vehicle go inside the airport area must be using green technology. But they haven't solved anything for the aircraft yet because we don't have any electric aircraft, 100% electric aircraft. So the only thing we can do with will be using hydrogen aircraft. So here will be a kind of the summary for the zero emission tasks for different airports in the world. You can see that in Finland, a lot of the European countries, they tend to have a zero emission target for the airport. So zero emission, that means not only for the ground vehicle, for everything. So the ambition is quite high. So that means I'm not quite sure between that today or 2025, we will 5 more years for major of the airport try to become zero emission. So, but however, the aircraft itself, not many aircraft are zero emission. They're major emission actually for all the aircraft. So this table looks interesting, very good and very ambitious, but I'm not quite sure how they can able to do that. Well, a few major aircraft manufacturers and or research company like Rolls-Royce, they have been looking in hydrogen jet engine system. And they also looking into hydrogen fuel cell system. But I don't think in 2030 they are able to catch up. Because manufacturer of an aircraft need at least 2 to 3 years anyway, not 2 to 3 months. So this table is interesting, but we can see the mission, the theme for all the airport, what they try to do anyway. So that means the thing we need to work on hydrogen fuel has been promoted in aircraft. So what we can see will be hydrogen storage will be important. Hydrogen power aircraft, we can use fuel cell or using the fuel jet engine to do the job. In this case, we can able to have really zero emission. And also we try to prove the technology for hydrogen. We have been doing a lot of good work for ground vehicle, fuel cell, hydrogen storage on the ground surface. So this technology is really nice for us to move on to the sky, become the aircraft application. So the technology here, but we need further push for the government, next generation, try to move on to aircraft. And also public interest. We all know that the major emission is aircraft. The thing is aircraft usually would be account for 1/3 of the total emission. Ground vehicle, we already improved so much because we have using a lot of the EV. But for aircraft, we see a major problem because they're international, they need to travel for long hours. So that means to use battery is impossible. So that means the public image will be, we need to do something for aircraft. The only solution we need to do will be using zero emission fuel, like hydrogen. There's no other choices. So that means hydrogen will be only choice. So that's why research is really going on for hydrogen vehicle, hydrogen aircraft. In terms of the economy point of view, hydrogen fuel is still expensive. But however, if you're looking into the near future option, the carbon tax and also the cooling system, then still possible we can move on to hydrogen fuel for aircraft. So that means we do have more possibility for hydrogen aircraft as compared to the gasoline aircraft. So we wait and see anything could happen. So what do you think? Up to now, do you think hydrogen aircraft will be more possible? Do you see the future for aircraft system in 10 years, 20 years time? Do you think it's ready to use hydrogen aircraft? What do you think?
I think for the hydrogen aircraft, there's also a challenge for the hydrogen storage in the aircraft. It needs higher pressure to store the hydrogen.
I think we still need at least 7 about. I think we're actually using liquid hydrogen. Of course, the high pressure good storage, pressurization system, we need it. All the hydrogen aircraft basically can move on to liquid hydrogen, that means minus 260 degrees C. But the technology here, we are able to do it, not for vehicle, not for ground vehicle, for aircraft, we got more facility, we got more margin to use liquid hydrogen in aircraft. So what do you think?
I think ammonia would be a better choice. Because the hydrogen would be kind of difficult. Because for a long flight, we will need a much larger tank for hydrogen, right? To store that in a pressurized form, and the tank's weight is going to be like too much.
That's true, yeah.
I think for maybe it is might be for short range. Not long range. Okay.
And also, if they start using hydrogen in aircraft, so they will also have to manufacture hydrogen in a green way, and that also needs a lot of infrastructure right now, because right now it's just way too expensive. And why would airlines do that? And if they raise the prices, people would say just go back to carbon emissions. We don't want to pay so much for the flight. Right?
What do you think? Just
Well, it's obviously much more likely that they'll develop there's more push to develop for aircraft versus vehicles because batteries are not really an option for aircraft, right, because of the weight. So while these are all issues, while like green hydrogen, production of hydrogen or storage of hydrogen, they're much more likely to try and advance that technology for use in aircraft, right? Because there's no other option. It's either jet fuel or hydrogen or ammonia, yes. But batteries are not an option. Only for short range, actually, very short range batteries can be used. So then you need something else for longer range. So then, there is an economic reason to start using hydrogen. Because eventually, if you want to be zero carbon emission, you need to use it. You don't have a choice.
That's true. I think all your comments really good. I think for really short range, we can use battery. For medium range, we can use hydrogen. For really long range, hydrogen is too expensive. Probably quite impossible. At the moment, hydrogen cost is still so high as from the analysis, 10 times. Impossible. I mean, our flight ticket already expensive. But in the field will cost half of the flight ticket. That will be another 5 times more expensive. That will be impossible. So that means that unless the hydrogen field can be much lower, but I don't see that in the near future yet. So without lower cost for hydrogen, I can't see any future for hydrogen field with hydrogen aircraft. Only for medium or short range. But zero emission for aircraft, the only solution might be hydrogen or ammonia. Cannot be battery, impossible. I don't think battery energy density can increase by 10 times. Impossible. At least I think the battery energy density is increased by at least 20 times. Important to good for the aircraft. Because aircraft usually for the national travel, right? So that's why a lot of question in there. But anyway, let's stop here. We can continue on Thursday then.